Hello everyone, welcome back to Magad Gyan Kane. This is the first part of the new topic, motion. First of all, we'll see what is motion. So when we say that any object is in motion, when it is changing its position with respect to time, with respect to a point of reference. If we don't have a point of reference, we cannot say whether an object is moving or not. For example, if we are sitting inside the bus and if we look at the person who is sitting beside us, we'll say that he is at rest. But a person who is sitting outside the bus or who is standing outside the bus would say that both of us are moving and the bus is moving. So a point of reference is very important if we are talking about motion. So our first point is distance. Distance is the length of the total path covered by an object. So for example, if we are supposed to go from home to school and the distance from this point to this point is 5 km, this point to this point is 2 km, and this point to this point is 4 km, then the total distance traveled by the person would be 5 plus 2 plus 4, that would be equal to 11 kilometers in total. So in this example, the distance would be 11 kilometers. So our next point is displacement. Displacement is the shortest path between any two objects. It is the straight line between the initial position to the final position. So in this case, earlier the distance was 11 kilometers, but if we have to take the displacement, it would just be a straight line drawn between them, and suppose this was just 11 kilometers. So earlier they had to follow a path, but in this case, when we are talking about displacement, it's just the straight line between the initial and the final position. Now, displacement can never be greater than the distance traveled. It can either be smaller than the distance traveled or it can be equal to the distance traveled. As we learned previously that displacement is the shortest distance between them, so it can never be greater than the distance. So displacement is a vector quantity, meaning it has magnitude as well as a direction, whereas displacement is a scalar quantity, meaning it only has magnitude. And displacement can be negative, positive or zero, whereas distance can never be negative or zero. It will always be positive. On to the next point, speed. Speed is the rate at which an object covers a certain distance. Speed is expressed by distance upon time. So the SI unit of distance is meter and the SI unit of time is second. Therefore, the SI unit of speed would be meter per second. Speed is also a scalar quantity because distance is a scalar quantity as well. Now our next point is velocity. Velocity is the rate at which an object displaces. So we express velocity as displacement upon time. As displacement is a vector quantity, velocity is also a vector quantity. The SI unit of displacement is meter and that of time is second. So the SI unit of velocity is meter per second. Now the last point of this video, the acceleration. Acceleration is the rate at which an object changes its velocity. So we will need to visit some symbols. So V is equal to the final velocity, U is equal to the initial velocity, T is equal to time, and A is equal to acceleration. So the expression of acceleration is equal to final velocity minus the initial velocity, which would be the change in velocity, divided by time. And the SI unit of acceleration is meter per second square. Acceleration is also a vector quantity because velocity is a vector quantity as well. Thank you for watching. This was it for this video. Make sure to subscribe to our channel for later updates.